In this video, we're going to add to our matter tree. We have learned that chemistry is the study of matter and that science is all about classifying and organizing, as well as experimenting. And over the past couple weeks, we have been classifying and organizing our understanding of matter. The first thing we did was break matter down into pure substances and mixtures. Actually, mixtures came along later, but pure substances. And we saw that pure substances could be either elements or compounds. And we saw that elements are either metals or they are nonmetals. And compounds are either ionic or covalent. Then we actually talked about mixtures. And mixtures is kind of hanging up here a little stilted. There's nothing under there. Well, in this video, we're going to add to our study of mixtures. There are two kinds of mixtures. There are homogeneous mixtures, and there are heterogeneous mixtures. Well, what do I mean by that? Well, we've seen before homo. Homo is a prefix that means same, and we've seen before the prefix hetero, and that prefix means different. So we classify mixtures by breaking them down into mixtures that are the same throughout the entire mixture and mixtures that are different depending upon where you sample the mixture. A homogeneous mixture is going to have the same composition throughout. What would be some examples of homogeneous mixtures? Well, Coca-Cola would be a good example of a homogeneous mixture. No matter where you drink from in the bottle, you get the same formula of Coke. Another common mixture is the salt water in our oceans. And one that you might not think of as being a mixture at all is the compound steel. Steel is a mixture of iron and carbon. The iron gives it strength and the carbon helps it to stay rigid. And so steel must be the same composition throughout in order for it to fulfill its design. Heterogeneous mixtures, on the other hand, will have a different composition depending upon where you sample. We could actually say they have a different composition throughout. What would be some examples of heterogeneous mixtures? One that might be good to remember is a bowl of cereal and milk. Another one that's easy to imagine is Italian dressing. The reason you have to shake the bottle is because as you let it sit, the composition changes again because you're trying to mix oil and water, which you really don't want to mix. So here we have two branches that we can add on to mixtures in our matter tree, and let's reproduce the examples underneath of each one. Homogeneous mixture examples were salt water in the oceans, steel, and Coca-Cola. Heterogeneous mixtures were cereal and milk and Italian dressing. Now, our atmosphere is also a mixture, but would the atmosphere be a homogeneous mixture or a heterogeneous mixture? Well, actually, the atmosphere around us is a homogeneous mixture, not a heterogeneous mixture. And we've talked about the composition of air before, and so I hope that you will remember that air is mostly nitrogen. Our textbook says 78% nitrogen, 21% oxygen, which leaves 1% of everything else. Although we know that the third most prevalent gas in the atmosphere is, in fact, argon. And so we go back to our matter tree, and the first division is matter can be divided into pure substances and mixtures. Pure substances can be either elements or compounds. And we now know that mixtures can be either homogeneous or heterogeneous. At the next level, compounds can be either ionic or covalent, whereas the elements can be either metals or nonmetals. And so there you have our more complete matter tree. I'd like to finish with a word about milk. Milk in the United States is homogenized. Milk fresh from the cow is not a homogeneous mixture, it's a heterogeneous mixture. In the old days, the cream would rise to the top, and if you poured all that off first, then what you were left with was skim milk. But by the process of homogenization, they are able to take a heterogeneous mixture and homogenize it or turn it into a homogeneous mixture. I don't know what they do in Japan. And that concludes this video.